Today we're going to look at simplifying roots. Now, one thing that's helpful in simplifying roots is remember how to do a factor tree. Now, this one is even, so I know a 2 goes in there, and still even, so I know a 2 goes in there. Ends in a 5, so I know 5 goes in there. And the digits add up to be a multiple of 3, so I know 3 goes in there. But I also know that 9 and 7 go in there. So we can take a look at what we have here at the ends. And our prime factorization of this would be a 2 squared, because 2 shows up twice, a 3 squared, because 3 shows up twice, with a 5 and a 7. So remember, that's how we do prime factorization, or a factor tree. Okay, a couple other things here. Here we have a square root, which really means there's a 2 in our front for index. That's the root we're taking. So we're taking the second root or square root of x squared. Whenever this matches this with a root, then they undo each other and we just get x. Here, this matches this and they just undo each other and we just get x. That does not work over here because the number on the inside does not match the number on the outside. So I'll write down cube root. But remember, we could write this as an x cubed times an x squared. Remember, x to the power times x to the power, we have to add our exponents, and you know 3 plus 2 is our 5. So now we can go ahead and do the cube root of this. Because these match, they undo each other, leaving us with an x. Now, with this right here, it doesn't match, so we have to just leave that in there. And when the exponent on the inside is smaller than our index in front, there's nothing we can do to it. Another thing that you need to be aware of is if you have two terms added together, its conjugate, and that's going to come into play later, is basically those two same things, but just a subtraction sign. And it also works if this was a minus sign, then the conjugate would have a plus sign. So here, all I'm going to do is just do a prime factorization or a factor tree. So 3 goes in here, what, 49 times? And then we have a 7 and a 7. And so I can go square root of a 7 squared, because that's, you got to look at what's at the ends of all your branches, and a 3. So now we can look at this, the square root of 7 squared, because this index in here, which isn't written on the square root, matches our exponent on the 7, they cancel, and then we're still going to be left with the square root of 3 we can't do anything with. We need to do that same type of thing on the problem here on the right. First of all, we got to start off by doing a factor tree. It's even, so I know 2 goes in there. That's even, so I know 2 goes in there. That's even, so I know 2 goes in there. That's even. That's even. That's even. And then I know with 4, that's a 2 and a 2. So if I count up at the ends of all my branches, 1, 2, 3, 4, 5, 6, 7, 8. This is really a 2 to the 8th here for this. And then I also have an x to the 8th and a y, all inside of my 5th root. Now you'll notice with the 2 and the y, my exponents are bigger than my index in front. So I should be able to rewrite that as a 2 to the 5th, and then I'd still have to have a 2 cubed so I can get that 2 to the 8th. Then I'd have to have an x to the 5th, and then another x cubed to get that x to the 8th. And then I'd have to have a y. And then I got to make sure my root goes all the way over. So now, anything which has the exponent that matches our index in front, means we can go ahead and pull those out. So I can pull out that 2, and I can pull out that x. And I'm going to still have the fifth root of all that other stuff left on the inside. Now, since these exponents on everything on the inside are smaller than our index of 5 in front, we can't do anything with it. If you wanted, you could go ahead and rewrite your 2 cubed as an 8. Does not make a difference. And then we can get our answer. And we're going to just continue to do things like this. So now you guys know how to add and subtract like terms. Here, all of our roots are different, so we don't have any like terms. However, when we look at this, this is the square root of a 2 squared and a 5. Our 54 is a 3 squared and a 6 because it's 9 times 6. Now, up front here, we just have a root 6, and we can't do anything with that. So we're going to just basically simplify each one of these roots first. We can pull out our 2 from the green root, be left with a root 5. We can pull the 3 out of our red root. So now our like terms are those that have the same roots. Negative 3 of the root 6's and another negative 3 of the root 6's is negative 6 of the root 6's. And then we still have this. There's nothing more we can do because our roots are different, so they're not like terms. Now, over here, you'll notice we can simplify these roots. Now, if we go back, that's 64. Now, 64, once again, going back here on the previous page, 1, 2, 3, 4, 5, 6 is 2 to the 6th. And then our 96, we need to do a factor tree on our 96. So 96 is a 2 to the 5th and a 3. So I already have that 2. Now, when I look at this, since the exponent on that 2 matches, I'm going to pull that out. I'd still be left with the 5th root of that 3. Oops, and I forgot my plus sign right here. And then when I look at the next part, that's a 2 to the 5th and another 2 to the 1st. And then the 5th root of a 2. So when I look up here, 2 times 2 is 4, so I can go 4, 5th root of 3, plus, and now this is really a 3 in front, 5th root of this, and then I'd still have the 5th root of that 2 to the 1st. Now, that 2 times 3 in front, I'm going to just erase and go 2 times 3 and write 6. But that's where that 6 comes from. Minus this. So like terms would be our 5th roots of 2. So we can't do anything with the green, so we'll leave that there. Then in the red and the black, they're like terms. We have 6 of the 5th roots of 2's minus 1 of the 5th roots of 2's, so that would leave us with a total of 5 of those 5th roots of 2's. And that would be our answer. So we need to multiply our roots together. In multiplying roots, you can write it as one big root and then multiply what's on the inside. So I can go the 10 times the 5. Now, I know that 10, I could write this as just 50, but then I'd have to do the factor tree. And I know that 10 is a 2 times a 5. So the 5 from the red 10 and the 5 from the green would really be a 5 squared. So now I can do the square root of that 5 squared. That comes out in front. I can't do anything to my 2. I'm going to leave that. Over here, we have a root times another root. Really, it's multiplication between the 4 and our first root. It's multiplication here. And then it's multiplication between the negative 5 and our root. Now, if you wanted, you could try to simplify your roots and then multiply, or you can multiply and then simplify your roots. It doesn't make a difference. We have 4 things multiplied together. So what you can do, since you can multiply in any order you want, I'm going to multiply the numbers in front together first, and that's a 20. And then I'm going to go ahead and multiply what's inside my roots together. So I'm going to have this 15, which I know is a 3 times a 5. And then I'm going to have my 20. Now my 20, I'm going to think of as being a 4 times 5, or 2 squared, and another 5. Now, could you have multiplied it all out into one big number? Yes, but then you still have to do a factor tree. So I thought about what makes these numbers up and just wrote it out like this. So now I'm going to go ahead and write it as one big root. And I have a 3 to the first. You'll notice I do have that 5 squared, and I have that 2 squared, which is good when I'm dealing with a square root. Remember, if there's no index in front, it's assumed to be a square root. So since my 5 squared matches my index in front, I'm going to pull out that 5. 2 squared, square root of 2 squared, I'm going to pull that out, and that's a 2. And then I'd still have the square root of what's left, which is just that 3. So then when I look at what's in front, I end up getting, let's see, 200 with a root 3 when I multiply that out in front. So that's how you add, subtract, multiply roots. When you're dividing by roots, we don't want to leave roots in the bottom. We need to multiply by a special form of 1. Now, to get this root out of the bottom, we need to multiply by the special form of 1. It's going to be a square root of something, square root of something. Now, we want to try to end up getting the square root. We had a 3. We need to have the square root of a 3 squared, because then we know that that bottom would simplify down to just 3, because your root would undo your squaring. So then you got to think, okay, 3 times what is a 3 squared? And well, in this case, that ends up just being another 3 to the first. So we'd already multiplied out the bottom, and then you can just multiply out the top. Well, it's just that 5, which is not in the root, times our root 3, and there's nothing we can do to that. So I'll just leave it like that. Sometimes when you do that, you'll be able to take something out of the root on the top. Now, this is going to be our answer. Sometimes, once you get the root out of the bottom, you can simplify what's in top, not in the root, with what's in the bottom that's not in the root. But in this case, there's no common factors between the 5 and the 3. So you're going to have to do the same type of thing here. You need to multiply by the square root of something, so that, since we're dealing with a square root, we have a 6 in the bottom. We need to get a 6 squared. So then you got to think, okay, my 6 here times what gives me my 6 squared? Well, that's just another 6. So it's a root 6 top and bottom. Now we've already worked out the bottom, so we know that the square root of 6 squared is just a 6. On top, we really have 2 terms. Remember, terms are things added or subtracted together times one thing here. So all I do is distribute through. So it's going to be a negative 5 with a root 6 by it, plus this is a root times another root. That would be a root 12. And since I'm running out of room here, I'm going to go ahead and just bring this down. Now, when I look at that top, root 6 is just a 2 times 3. I can't do anything to that. But when I think of 12 and do the prime factorization of 12, that is a 2 squared times another 3. So I can go ahead and pull out that 2 squared, pulling out my 2 squared right here inside from the square root is this. It would still leave me with the square root of a 3 there, and I'd still have what was in front of my plus sign. So when you look at 54, we have a root, but it doesn't work to do what we were just doing in the last two problems because we have two terms here. Remember, terms are things added or subtracted together. So that's where we have to go ahead and do that conjugate thing. And that's where we multiply the top and the bottom by pretty much the exact same thing as the bottom, but you have to switch the sign in between. So instead of having a minus sign, I'm going to put a plus sign. Well, then if I multiply the bottom by that, I got to multiply the top by that. So when we rewrite this, it's really two things here times two things here, and then it's just a 5 times that. So when I look at the top, I could distribute that 5 through the 5 times the negative 3, plus, and then I have to do the 5 times my root term. So the 5's not in the root, so it's not going to affect the root, but it's going to go 5 times the 2 in front, which is a 10, and I'd still have the root 3. Well, when we're doing the bottom, we have 2 terms times 2 terms, so we're going to have to multiply out the first terms, which is 9. Multiply out my last terms, that would be a negative 6 root 3. Then I'm going to have to multiply out my inner terms, which would be a positive 6 root 3. And then multiply out my last terms, a negative times a positive. Multiply what's in would be a negative. Multiply what's in front, which is 4. Multiply what's inside, which is a 3 squared. You will notice then these two right here undo each other. They're the exact same, but one's positive and one's negative. And we'll just try rewriting this since I just screwed it all up. Negative 15 for the top, plus a 10 root 5, or 3. Then on the bottom, we're going to go ahead, and these cancel. We just talked about that. Now, the square root of 3, you should know is the square root of 3 squared, I should say, is just a 3. So this is really a 4 times 3. So we really have the blue 9 minus 12. The blue 9 minus 12 is a minus 3. And that's our answer.